Hi, everybody. I'm still Ms. Lee. So we're going to go over the third type of equations that we're going over in this section. So we're going to go over the kind that's the exponential kind with the same base. Okay, so I'm going to go ahead and write out our example here. So we have 3 to the 4x plus 3 equals, and then 27 to the power of x plus 2. Solve for x. So as you can see here, the title of this section is called Same Base. But if you're looking at these two, you're seeing a base of 3 and a base of 27. Now, how in the world is this same base? Well, if you think hard enough about that, 3 and 27 can be considered same base because you can rewrite them both using the same base. So there is some number when you take it to a power that you can get both 3 and 27. So that number would be 3. So 3 obviously is just 3, so we're going to leave that as 3 to the power of 4x plus 3. And then equals, so what I'm trying to say is that 27 can be written as a power of 3. And so therefore, we rewrite this so that they actually do have the same base. So rewrite with the same base. And of course here, 27 is equivalent to 3 cubed. So we have 3 cubed to the power of x plus 2. Now, you should know that by property of exponents, you should know that what we want to do is multiply these exponents. And so you have 3 to the 4x plus 3 equals, and then you multiply these, and so you have 3 to the power of 3x plus 6, because of course you distribute, okay? So just so we write down the step, this is a step for simplifying. And what we're doing is distributing this 3 to the x and the 2. So what you'll notice now is that these two sides or expressions both actually have the same base now. And so if you say 3 to the power of something equals 3 to the power of something else, well, if they're equal, those two powers should be equal to each other. So we'll go ahead and set the exponents equal to each other. So set exponents equal to each other. Because again, if this is like, let's say 5, 3 to the 5 equals 3 to what power? Well, it's got to be 5. So no matter what, these two numbers have to be the same. So we're setting them equal to each other. We have 4x plus 3 equals 3x plus 6. And we subtract the 3x to the other side. So you subtract 3x. And you get x plus 3 equals 6. And so x equals 3. So just to reiterate, what we did here is you just solved algebraically. So from this point over, we solved algebraically. And remember, there's always this last step that a lot of you tend to forget. Is going to be checking your work, okay? Check your work. And so if you check your work, you set x equals 3 into the original equation. And so you have 3 to the power of 4 times 3 plus 3 does 3 to the power of 4 times 3 plus 3 equal to 27 to the power of 3 plus 2. So does that equal 27 to the power of 3 plus 2? Well, these numbers are getting a little bit large for me, so I'll go ahead and use my handy dandy calculator. And so we're going to do 3 to the power of 4 times 3 plus 3. And we're checking, does that equal 27 to the power of, well, 3 plus 2, that's just 5. So 27 to the 5th power. And yes, it does. And so therefore, x equals 3 does work, and x equals 3 is our only solution. Okay, so go ahead and try some practice problems, and I'll show you the fourth type of problem or equation we'll be solving this unit in a bit. Happy day.